music. Turn that over slightly. Hopefully the music's not too deafening. Yeah, hi everyone. Hope you're doing well. Okay. Yeah, so I guess the first thing to do, as we always do, is to have a look at where we were last week. So we got to last week. So we can look around and we can see the guy, or our first enemy character there. So I think the first thing we need to do really is make sure that the bullets, the firebolts, go in the direction that that we're actually pointing. So if you're looking down at the ground, looking down or up to the sky, we'll probably also need to add bounds on the firebolts to make them sort of when they hit the wall explode and stuff. Because I think at the moment it just checks the back wall to see when they're exploded. And then we also wanted to move the guy around, have him like shuffle around a bit. And I think for that we'll probably end up hijacking the camera so that we can make sure that he's doing what we expect. Probably some quite cool footage of us like following the guy around. So that's the list of things that are next to do on the game. But really we just need to get started. So the first thing is inside the player.rs. This is where we actually cast the firebolt from. And we want to change the velocity because at the moment it just spawns at the location and heads in a direction of 0, 0, so it's 0 in the x coordinate, 0 in the y coordinate, which is up and down, and just has the speed going forward. And actually we want to, so we have this, and I honestly can't remember what this was. So I think the first thing to do is just enable that and see what happens. Okay, well that's clearly not right because they're spawning and then they're going behind us. So I suspect that is the yeah. What's the look rotation? That's the first thing. So we alter the up and down. For sure, this wants to be that. Yeah, the other option is that we hijack the camera and we take the position of the camera and the looking at position and use those to calculate the velocity. But I think we can probably do it from the rotation because the rotation is what we're changing here anyway. So yeah, it's rotation up and down. So the x coordinate would be taking into account the, oh yes, no, it is taking into account the y. Yes, let's try hijacking bits of this. I don't know why it's multiplying by the cos. That feels wrong. So yeah, I'm gonna redo that and re-enable this, and then we'll just take these. We'll take the sign of the look at in the y direction because we're pivoting. You know, imagine a pin going through the character. We're pivoting around that, so we actually want the y rotation. Sorry, the rotation of the y axis, which would be the. Actually, maybe we don't. Yeah, I think we need to check on where we're actually getting the player rotation. Is there a get rotation? Or is it just public? Get look rotation. There we go. That's nice and easy to find. It's going to be inside the excuse me, inside the thing, the game update. Yep, that makes sense. So, excuse me, sorry, choking. I think I'm just dying quietly. Right, so yeah, so the lookout one is what's controlling the up and down, and and actually the X rotation. Excuse me, sorry, I'm gonna mute the mic quickly. Oh, there we go. Sorry, hopefully that's cleared it. Yeah, so we've got the X rotation. I think is that's the look at X and Y, and we're moving to the player location. So we've got the player location, and then the look at is this. So actually, I don't see why we can't just hijack this to find the look at. Look at is get player rotation, so that would be rotation. Oh, it's actually called look rotation. So actually, we can just do that. Self.one. Sorry, look rot, not look at. Okay, and then this will be self.location.x and self.location.z. Player lock y. Okay, yeah, no, it is the y. Okay, that's something. So let's go with x and y. And we'll just set that. We'll multiply that by speed. 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 And we'll see what happens. So that's in here. Okay, well, still not seeing any bullets, which does indicate to me that they're going behind. So let's set those to negative and see what happens. Okay, can kind of briefly see it flashing up. Oh, I did see it flashing up. Oh, okay. Yeah, so it's when we look down and they're heading upwards. Okay, so I think maybe let's set that to 0, 0 for now. Yeah, we definitely need to change the Z because otherwise that's going to be... Just going to make it slower as well so it's a bit more obvious where they're going. Okay, so they're going off to the side. Okay, yeah, that's really messed up. I'm gonna have to figure this out. So, okay, that's even weirder. The more we're so let's try taking the rotation into account. And we'll calculate the x speed. So that's going to be just 1 times the sine times the speed. Okay, let's put that in and see what happens. Okay, well that's definitely wrong because they're just sort of disappearing off to the left very quickly. So I think we're going to need to implement a debug statement. So let's put the we'll put that over the on here. So actually on the page. info. Get rid of that generated nonsense. Okay, and then here we will as well. There, and then we need these CSS files. Main CSS. Oh, there was an ID, wasn't it? Class. So position absolute top left. Yeah, white seems good. Actually, write debug in the window just to check, see if that appears. Yes, it does. Excellent. So now we can, on every update that to updates. Go. Right. So actually put it in here. So let's debug equal. Remember the get window element syntax. Okay, it's not in the create, in the update. No, it's in the view. No, rendered. There we go. Right. Okay, no, that's just looking for the node reference. Okay. 2 seconds. I'm going to call up another project. So I've done this before, but I just need to check on the syntax of it. So okay, excellent. Game updates. So this gets hold of the windows. This is recreating what you do in JavaScript. Get element by ID, debug output. It's not what it's called. It's called debug info. Okay. And then we just want to set the it's picked the location and the look at. Yeah, that might be enough. Okay, so we can see here the locations and the values that it's giving, and the look at. Stop me gonna move. There we go. So it's. I think those are just. Yeah, they're actually, the lookout is just rotations. So when we are, so now we need to map these onto the thing. So we've got our field of view here. This is the player location, and it goes from minus 1 point. Well, actually, we'll call it. Pi over 2, because that's what it really is, and to pi over 2, and then does it go to, yeah, it goes to 0 when you're facing straight forward. Okay, so the x speed should be 0 when that is 0, or the location. Basically, it should increase based on where it's going. So right, put at 0 degrees, x is equal to 0, and z will be equal to 1. Sorry, let's put z for 0 there. And then at pi over 2, they should be equal z, and at negative pi over 2, x should be negative z. Okay, so that gives us some sort of idea of how to map these. And it means that we definitely need the rotation for the Z coordinate as well. It's in here. So I think that's going to be. I'm actually just going to slow this down now, so again, so we can see it because they're disappearing off the screen. So we now have. Okay, that's a good start, but it's still drifting even when it's very close to 0, because that should be 0. So how's that? What's that calculation there? It's the right. Because it's using 1, which is the up and down, so that's why. So we want that to be 0, and I think that wants to be close. There we go. Just wait for it to reload. Okay, so try and get them as close to 0 as possible. Should we only using the X? There we go. Okay, nice. So. They're going in the wrong direction, so that's try and set negative. Okay, they are at least going in the vague direction we are looking. It's kind of working. Obviously, they're not facing in the right direction yet, but we'll calculate that in a second. So that's the extreme. It's going quite far, isn't it? It feels like when we're like right on the edge here, it's going far too far. So I think we need a bit of a fiddle factor on the rotation. So it's negative self.look rock.0.sign.speed. Multiply that by half and see what we get there. Of course, we need to set the x. Let's do the let z equals that. Drop z in there. Still not. So you should really be following the center point of the screen, and I think this is probably because we've not matched the camera to where we should be going. Okay, so half was better. Let's try it at a tenth. Okay, it's just moving really slowly now. So on the extreme, we're looking all the way over, and it's still drifting way too far over on the. And I'm guessing that the same is going to be true for that as well. Oh, actually, in the gosh, that's even worse. That's in the negative direction. It's actually kind of working. Kind of going. Oops. I think no, I know why. It's because the Z coordinate. So oops. Let's try and multi that. One. Just put in brackets to disambiguate it. I know that it's the same thing. Okay, and then we want to remove the block that we had on the speed. So that speeds up 10 times. Okay, still drifting off to the right, but it is kind of working towards the center. So the dampening factor is definitely helping, it's just not helping enough. Okay, that's too damped. 2, 5. I think we're also definitely going to need a sight in the middle of the thing, so we know where we're looking at. Yeah, it's almost right around there. It's just not quite. The other option is we just let the player shoot up and down, so you just go straight forward. But that feels a bit cheating. Maybe it's that we're dampening the response, and actually we want to dampen the rotation. Y equals self dot 0 times 0.5, and then we'll set that. Okay, so now we go back to here. Sorry, I'm rather paranoid, so I keep checking back on the stream just to make sure that the sound is actually working, but it does look like it's working. Ooh, that's much better. Okay. And then come from here. Yes, there we go. That was it. It was obviously, and it was off by a factor of 2, so that suggests there's something. I've made a wonky assumption somewhere in the maths. That's definitely sort of going in the right direction, I think. But we need to make sure that the angle of the firebolt is going in the right direction. So we're going to need to change the firebolts, and yeah, we need to calculate it from the velocity. So I'm going to have to draw this out because I've not really thought about this. Don't save that. So we want the rotation in the x planes. We're given for a vector of x and z. That's the x, that's the z. The rotation needs to be exactly this, but actually thinking about it, we've got the rotation already because it's just this rotation. So maybe let's try passing it. Y, and then in firebolt, model rotation 32. Let's try this, see what that does. Okay, it's definitely angling, but it's angling too much. It's not picking up the actual. see if it's off by a factor of 2 again. Yes, it was. I wonder where that 2's coming from. I'll have to sit down with the maths at some point, but there we go. Yes, that's what we should be seeing with. Okay, cool. So we can now cross over the things and all head in different directions, and they don't explode when they hit the wall. Let's try and aim just there. I'm going to test my theory that, yeah, so when I shoot and it goes through the wall, you can kind of see there's a little bit of the explosion that comes through. So, okay, that's solved that. Then we need to look at the Y rotation elements to make sure they go up and down. And that's just going to be, so we'll have a look at the values of the rotation. So 0 is looking up. So I think it might just be COS actually. Let's have a look at that, or let's actually x.cos times speed. Yeah, so once again, it's sort of right, but still, yeah, of course, because we had the issue, the hack that we had to put in here with the subtracting pi. So let's try and do that. Is that okay? That's going in the wrong direction. Let's try inverting the rotation. Okay, so it's possible the adding the 90-degree offset was wrong. Definitely not going in the right direction. Let's try making it a 10th of the rotation. And changing it to sine. So that at 0 it should be okay. Okay, so that's definitely the wrong direction. Yes, okay, excellent. So it's now going at least more towards the floor. Still quite going, still a bit exaggerated, isn't it? And actually, let's pass rod x in there so that we can add this would be the x rotation. Sorry, the Y rotation. Okay, well that's not. It's not doing. It's sort of tilting, which is not great. Because we already rotated it around there. So let's. Yeah, we already rotated it 90 degrees because of the model. Okay, not perfect, but yeah, I'll need to go and think about the actual maths of this. It's still drifting a little bit. Yeah, this is because all of the math so far is kind of a hack, really. But let's put a dot in the center for now. So we can put this. Later, of course, I wanted to put an actual image of a wand or a staff for casting. But let's equals sites. One of my least favorite things about Windows is randomly puts the, actually let's make it red. Okay, well, there is a site. It's sadly in the middle of the page, so we actually want it to be half of whatever the canvas is. And we're also getting very close to these. It's 400, 300. Left 400 x 300 px. So okay, that's not right. I got the things the wrong way around. And there we go. That's kind of in the center, and sort of where I guess there's a better frame of reference for where the firebolt is starting. So, well, we can at least fire the firebolts, and I need to go away and think about the maths behind ray tracing, and figure out why it's, or at least not ray tracing, sorry, the calculating the directions based on the directions of various things, and also thinking about the maths behind excuse me, the maths behind the maths behind how we actually calculate which direction we're looking in, because all of this was a kind of a hack together in the moment, and really it needs sorting out to be proper maths. So I think also I'm getting a bit fed up of it being so near the top, so I want to set the padding top, see what 50 pixels looks like. Cool, that's moved it down nicely. Then for the canvas, we want to set margin left auto, margin right auto. That should center it, I think. No, it doesn't. Okay. Just trying to do the simplest possible things. Text align center, did that do it? Yes, it does. Great. Okay, so it's now in the center at least, which means that when we overflow, we're not going to overflow clicking things. So that's all good. But now we need to revert this back to 50%. Oops. And 50%. That should put it smack bang in the middle of the image, which it does. Which is great. Cool. Okay, so not perfect, but we can at least fire firebolts around, going in different directions, and we can add the boundary checks in. So where the question is, where do we add the? Okay, yeah. So this was hard coded in here, and that's not good really. What we really want to do is some sort of collision detection, but I haven't yet figured out how I want to do the collision detection. So I think we're just going to have to hard code these in for now. So checking back, now that we have the debug notices on here, we can, or the debug notice at the top, we can see, okay, so the left point is at 2, right point is at -2 and left point is at 2. So say else if location X is less than -2, else if, well actually let's just add it as an or self.location.x is greater than 2. Okay, great. Yeah, it now pops into the wall and we can see it exploding. Oop. Cool. Now we just need the z. So else self.location.y is less than 0. I think the floor is at 0. Yes. There we go. Great. One thing I did want to do was to look at the shards, and the shards, if the self.position.y is less than 0, oh, that's interesting. It suggested that we put some bounce in it. Let's just see what that looks like. Okay. Yeah, they kind of bounce a bit. That's fun. Okay, I think they're bouncing too high though, so let's. Okay, well now they're not bouncing enough. I think I know why. We actually want to. Oh, well, there's a big green thing there. I wonder what the green thing is. Oh, it's the it's the skybox. That we didn't make the sky big enough. Is it because it takes the initial? Oh yeah, it's because it takes the initial space when you refresh the page. Well, we're gonna have to deal with that. Okay, that looks quite cool, but I kind of want to put the bounce back in. So let's try 4. Okay, refresh page. There we go. Yeah, that's quite fun. Yep, there we go. They got a bit of a feel to them, make them feel a bit more organic. We'll fire into the wall. Yep, same sort of thing. So yeah, cool. Okay, well, like I said, not perfect, but we now have the ability to fire things around, have them scatter on the floor, meaning that we can start to animate the little guy as well. So just going to do a quick check where we got to. How long have we been streaming for? 40 minutes. Okay, yeah, so we normally try and, or I normally try and make them about an hour and a half. So we'll see. See that. Just have a look at the code. Clean all that up. Then, yep, we want those. Add those bits in as well. In the game, what have we got? We've got the debug info in the site, and adding the debug info to the top. Then, okay, well, I think now that we've implemented that, we can probably get rid of all those old comments. Great, and add those in. So, let's firebolt in direction of looking, sort of, and bounce shards. cool. I'll oops, I've got the styles for it's a terrible commit message, but it's what we've got in the moment. Okay, so now we can sort of hit the guy. At least the firebolts go through him. We're going to need to do collision detection, and we also need to move the guy. And really, the moving of the guy was the thing I wanted to get started on this week. So I kind of want to make him. I just want to make him rotate to start with. The reason is because each of the limbs is actually handled separately within the object that we've created to control the enemy, and it will need to align each of those pieces. So I'm just going to make him spin, close down all of this noise, we'll keep game open, and then we've got enemy wizards. Nope, it's enemy. Go. Okay, we have the rotation set here. Do we call the update? We do. Excellent. So for now we'll just do self.rotation plus 0.5 over time. Okay. Okay, yeah, so we've got the new rotation and we're setting the position for the guy and for each of the limbs. Okay, let's go for a bit of a sort of exorcist theme, and just spin the head to start with. So, okay, well that's obviously way too fast. You can see his head is just spinning around way too fast. So we'll make that 0.01. Okay, still rotating way too fast. So I'll add another 0. 10th of the speeds. There we go. Yeah, that's what I wanted. Okay, now he's got a sort of owl-like quality to him. Great, and we'll add the rest of the rotations in as well. So self.body model rotation. Okay, we can see that, yep, the head and the body are moving together. And now comes the tricky part, because we want to do the left arm set rotation, self rotation. Oh no, hang on. Oh no, that is right. Yeah, we want to. Yeah, sorry. Thought it was. It's just a left arm model. Okay, now this I think is just going to make it spin in place. Yes, it is. And we actually need to relocate it based on the rotation. So plus 0.15 plus self.rotation.sign. Plus self.rotation. Actually, I think we want this to be. The question is it normalized? That's the. Let's just do the x coordinate for now, see if that. Okay, well that is swinging way too wildly, so that's obviously too much. Let's try and multiply by the fiddle factor we put in. Let's see what that does. I'm not even really sure what that's doing. So, okay, let's undo that. I can't remember why we had to put the fiddle factor in. Oh, right, because it's not centered, it's taking the, okay, yeah, so we want the self to left arm, no, sorry. Left arm pos equals that. So it needs to be the position. So it's the position plus 0.15. There we go. I think that's it. It's that, but it's the cos because we want it to be 1 when it's in 0. Yeah, let's give that a go for now. Okay, yes, so the x is correct, and it's correct on both the left extreme and the right extreme, and now we just need to add the sign there. Oops. Figure out the correct. Yeah, what's the self position Z? Yes, there we go. That is it working. It's got the right thing. So we can now extract that. Actually, finding the music's quite quiet. Turn it up a little bit. Just a very quiet track. Turn it down again. Okay, so we'll put this calculation back in here, give it that variable, and then we just need the opposite. Have I guessed it correctly? Yes, I think so. Okay, well, so the right arm is still working correctly. The left arm has disappeared. I think that's inside the model now. Maybe the Z needs to be plus. Okay, well, we can at least see it now. Definitely going in the wrong direction. So that's. I thought that worked. So where is the? Let's try making this a bit more of an extreme factor. Just to see what happens. Oh yeah. Oh no, we are changing the rotation. Did we set the rotation? We did. We've got to take into account the fact that we set the rotation up here. So yeah, it is 15 as I expected. Before it's this plus 90 degrees. There we go. Okay, so now he is rotating, and we just need to do the feet. And I think we can probably just follow the same as before. Oh, okay, yes, we shuffled. Yes, they're not perfectly centered, so that's fine what this is going to do. I don't think this is going to work. Yeah, it doesn't. Should stop. Okay. Times I think that's correct. Is the foot is in the right place each time in the X plane. Now we need to do but of course we're not trying rotation, because you're going to move the direction model now. Rotation. Okay, that is almost there, just pointing in the direction. I suspect it's because we added the rotation. Yeah. Okay, well, it's definitely 180 degrees in the wrong direction, so we need to add 32 const pi. I think the shoe was facing in the wrong direction before and we didn't notice because it was too far away. So that fiddle factor we put in of the 0.55, let's try taking that out. Let's see if that then puts the shoe in the correct place. Kind of. Okay, that was too far back, so stop it. The suggestions are helpful sometimes, but sometimes they're just really annoying. I find myself really hammering on my escape key to tell it to disappear. Okay, it didn't like that for whatever reason. Why didn't it like that? Oh, we've lost it. Keywords for some reason. Okay, better, not best. So let's try shuffling forward again, just a little bit. Is it me or did that seem to get even? Let's try something 0.2. It should jump out in front now. It's just disappearing up. Where'd it go? Okay, it's. Oh, yeah. Okay, so this is 0.65 plus 0.55. Rather than try to do it in my head and embarrass myself in the stream, plus 0.65. Okay, so we set that as this value. Both of them. Okay, yeah, now it's too far out. Actually, I've realized this only works when it's centered, so we need to calculate the so call that shoe offset. Make that 1075. Okay, what does that do? Right. Yeah, all that's doing is moving it out in the x direction. We actually need to calculate. So we'll put that back to 0.625. Right, and then we need to invert them. Okay, so yeah, I've got it now. So we'll say shoe offset x equals that plus was it minus 0.055 times self dot rotation dot sine. Z equals oh no, it's plus, isn't it? Plus. Okay, let's have a look. Nope, that's not quite right. It might be this. There we go. Yes, the foot is now staying relative to the body. Great, okay, and we can just copy these calculations again. Rotation, yes, because the rotation will be the same. Then actually the shoe offset X and Z. No, actually I'm gonna create them separately because I want them to shuffle later on. So I'm going to calculate each one separately. This then needs to be minus. Oops, no. Yeah, that's adding the offsets, and this needs to use the offset X and offset Z, and this rotation, and I will add the blah blah in. Okay, nice, but it's gone too far on this one, and I think it's because we need to add the 0.5 there and subtract it from dx. Yes. Great. Cool. Okay, so we now we can set the rotation of our guy and have him move around, and we can fire the firebolts to the floor and chase him around. So I think what we'll do, so this means all the model lines up depending on there. We'll sort out the actual shoes shuffling around later. But let's move him from side to side. Let's see what that does. It suggested that we add signing colours. Okay, yeah, that's very fun. So now he's moving around in a circle. Yeah, that looks... Let's actually have him rotate in the opposite direction to the one that he's... Oh no, sorry, it's still taking the... It's using the rotation. So it should have him going in a circle, yeah, and facing that circle. Okay. Cool, that gives us a nice little movements there. So, okay, so I'm going to check this in. Rotation based on rotation and position. So check that in. Then really we want to start calculating the positions to make him move between places. So my thought with it was that they would have probably a zone that they can be in, and then they'd pick a random location. So they'd be stood somewhere, pick a random location, say over here, shuffle over to that location, turn, face the player, and then fire a firebolt. But I think the best thing to do would be just for now pick a location and make them move to it. So we need to create a placement here for destination. We'll create it as a location 3D. I don't. We also need to have a look at the bounds. So obviously it has to be between minus 1.9 and 1.9, and it will need to be, we'll need to bound it to the room, which I think, given that we're at minus 9, I think if we set it to minus 7 and plus 7, that should be good. So actually, we could probably set it to plus 9. So and then minus 7. So we can also spawn at a random location. For now, let's leave it so you can set the location as you set the thing, and then destination equals. Okay, just there. Actually, that's not terrible. Yeah, it's. And then we'll actually just create the set new destination. Okay, well, let's come up with some stuff. That gives us a new. So it sort of generated this code, and I'm just having a look at it, and it's if you get within 0.1 of yourself, then you set new destination. Yeah, else let's did we create a const? That's the thing we did. Excellent. Okay, const move speeds. Yeah, we'll set that to 0.01. Actually, I think that was what we wanted. Target angle, there we go. Yes, that looks correct. So we get the arctan of those. Actually, we want the yeah, and then we'll create an enemy turn speed as well. Const enemy rotation speed 1. Is that, yeah, 0.1. Use that, and we'll get rid of the artificial position movements. Else if self.rotation is not equal to target angle, then if okay, so yeah, target angle minus self-rotation plus, I have no idea what all that stuff is, so let's not keep that because I don't know what that's doing, and what it's trying to achieve. Equals targets angle minus self-rotation times if angle diff is less than oh, stop throwing out the text, very distracting this. It's less than the rotation speeds. Then self.rotation equals target angle. Well, yeah, we're always positive because we've used an absolute already. Oh, wait. Yeah, it's... Oh, for goodness sake. This... Okay, so now we need to create consts. We'll just import all of the consts because it's fine. You should never have a circular. Never a circular reference with those because they should only be consts. Nothing actually importing. Is the code gone? Okay. So that should. So we should be able to see. Okay. Well, that has done something. Okay, he's just rotating faster and faster. Why? That's so weird. is it doing that? It's just because it's... Okay, well I think this code is correct. I think it's to do with the target angle problem. And it's because the... Yeah, so I think actually we want to add a fiddle factor in here because of rounding errors essentially. .abs is less than 1. Well, it just disappears at some point. Great. Okay. Yeah. Now he's not rotating. That's what we wanted. Okay. Else, if self.position.x is not equal to self.destination.x or self.position.x. Yeah. Right. Else self.newDestination. Great. So should. Okay, well he's disappeared right off the map. That's probably because we didn't set the bounds on here. Yeah, he's just run off. Okay, so what's range? Range is no. This is all wrong. So. Can reuse the random number. What do we say the bounds were? So the bounds for Z were +9 and -7, and this is -2 to +2. Yeah, they're inverted in our actual world, but that's okay. So destination X is going to be random number times 4 minus 2, and then will give us a range of -2 to -2 to +2, and then we need to add 7 and 9 together, so we get 16. So we need this times 16. Must be a 0 because that's wrong, and then we subtract 7. So that should comment that out, and let's see what happens there. Okay, he's still moving incredibly fast, so I'm going to move the rotations. Yeah, let's. I strongly suspect he is moving in the wrong direction. Picked the Y. I think that should be the other way around. Okay, it's still not facing the right direction. And we probably want to know where the destination is. So let's add that to our debug in here. We'll just create some debug functions here. Get location and get destination. Rotation. Then we'll just copy this from here. Target angle. Great. And then search here. Player location. Great. Question is, does it want I don't know if it wants a BR. It does want a BR. Yeah, so it wants a line break because it's HTML. So first, if that's an enemy, excuse me. Okay. So the good news is he did go to a location and he got there, but he's obviously stuck on something. But the rotation thing is a bit worrying, so that's why I think we need the. Okay, so this enemy gets location. Let's use enemy destination. Destination. Let's get rotation. Enemy out equals enemy get rotation, and let enemy target angle. Let's get target angle. Right, let's try to do else. Let's enemies. That's what this do? Right, enemy locked on X. Okay, great. Just copy that 3 times. So that figured out the just X. That's what it says. Great, cool. Okay, yeah, I figured that out, and then we'll just return enemy. That's do that. Okay. Needs a colon on the end. And it builds. Excellent. Okay, so we can now see the. Okay, so he's trying to go to. So I don't understand why the rotation and target angle isn't working. So let's try and figure that out. Because he should be stopping to turn before moving. And he's moving in totally the wrong direction. Oh no, he's not. He's moving in the right direction. Sorry, I'm just watching these numbers tick down. So this is moving, and that is heading towards a positive value. The Y obviously has always been superposed, but the X isn't changing. So that's definitely worth looking at. Oh, it's because the rotation. Yeah, I think it's because the rotation's wrong. And it means that it's not hitting this. So there's rotation minus the target angle. It's not returning. Okay, so. Yeah, let's output the thing so we can see exactly what it looks like at that point. Yeah, the target angle is minus that. Okay. It's all rotating. You should see a rotating sign, but it's not. Rotation minus target angle, perhaps. Is this thing? Put the wrong sign. Don't Okay, right. Well, he's turning in the right direction now. Great. And is okay. He's moving very slowly. So that's going in the wrong direction. So that's sort of wrong. But he is moving forward, so I don't really know. Yeah, it's just going to keep going through the wall there. Okay, let's see. So yeah, I don't know how it's messed up the getting the angle. I think the target angle is wrong. Let's try changing the things around. Just do this. Ah, yeah, these were different. Oh no, were they? So let's make this the self target angle. We'll just call the function internally. We can be sure. Right. It's definitely going the wrong way though. At some point we're going to need to figure out what's causing that spin. Okay, well the good news is they are, I think he's now heading in the right direction, but the rotation he's picked is 90 degrees out of whack. And the question is, over long distances, if that fiddle factor of yeah, actually, I realized we don't want to take the destination rotation. Let's see what happens when he gets to the right location. Okay, well, he's definitely gone further. Yeah, I think the fiddle the fiddle factor is causing a bit of an issue. So we want to set the oh yeah. Why? Yeah, that shouldn't be like that. That's almost certainly what's causing that crazy spin. Okay, nice. So it's turning negatively towards the target angle, very slowly. Which I realised because we had two different rotation mechanics going on. Then starts moving in the wrong direction. So that's okay. Let's try changing the angle back to Z-X because I think that was correct, and change the rotation speed to 0.1 as well. It's so painful to watch him turn around that slowly. So moving in the right direction. He is not. Why? That was this. I mean, the Z movement's correct, but It's not actually facing the right. See what happens when there's a positive angle. Okay, I mean it's moving, but it's so we're going to force the angle to be correct, and the movement should always come from the target angle. Let's try subtracting, because I think that's going in the wrong direction. Supposed to be heading towards 507, which is all the way down there. And the X is going in the wrong direction as well. Which I think did it say I was trying to use cos before? Maybe that's where I've gone wrong. This looks more like it, actually. Although I think that, yeah, the X is about to overflow. Let's see what happens when it gets roughly to the right location. Actually, let's change the bounds of the destination. -7. Yeah, that should keep him within, just keeps him a bit more bounded, closer. Save him having to go. Okay, well that. Yeah, it's moving away. I do not understand this. Maybe. This could be a winner. I mean, other than the rotation of the model being wrong, but. Here. Oh no, he's overshot the Z location. Try subtracting there. This could be it. Yeah, we'll stick with it just while we're doing that. I'll change the speed, only speed as well. Oh, if I save it, it's going to refresh the page. Okay, we're nearly there anyway. No, it's overshot on the X. And the Z as well. Madness. Oh, it didn't refresh, that's weird. Did I actually make the change? Oh no, I never changed it. There we go. Okay. Oh, it should be there now. There we go. Yeah, off into the wall he goes. It's definitely heading in the wrong direction. Okay, so I think the best thing to do is to sort out this code here. So we'll get rid of that. Yeah, that does it. So we're now just going to ignore the rotation, so it should just move around facing forward the whole time. Okay, yeah. Took out the hard code to jump to the angle. Okay, that's good. X is going in the wrong direction there. That's okay. I'm going to need to take a small break. I'm just going to just a very quick comfort break. We'll come back and create some tests to get around this. I will see you in a minute. Okay, and back. So, right. Yeah, so testing. That's going to be, I think it should work with, yeah, I can just set it up and do test, I can't remember the testing format now. Here, let's go to projects. Config test, that was it. Config test, and tests. Use super. Okay, so actually we just want to test turn 2. This is yes, what I'll do is I just want to see what the output of these was, and put in some known locations. So that's what we're testing. Let z equals wait, hang on. No wonder these are so random. It's not taking into account the current location. Yeah. Oh, I'm such a dingbat. Right, so yeah, so we need to get the angle between oh, it's the difference, isn't it? Yeah, okay, so, right, so lock x equal to 0, and lock z equal to 0, 0. If we want to go to dest x is 1, dest z is 1. Actually, let's get such a simple one. We need the difference. Ambiguous numeric type float. What? Why is that ambiguous? Oh, okay, right, it's assumed there. Okay, I think we just need to specify for each of these. Specify the type. Yeah, okay. Okay, so, and then if we let destination z equal 1 and let dest x equal 0, difference again. Yeah, and then it should be 90 degrees. Great, okay. Oh, thank goodness, right. I think if we that and green users, we can just alter our angle. So it's self dot destination dot x minus self dot position dot x. Yes, there we go. Right. Okay, reload the transserve. Okay, yeah, and now we just need to correct what mistake I made here. Just to alter the signs of the movements. Go. It's going to different locations, bouncing around. Excellent. Put the rotation code back in. Actually, let's put this code in, just make sure it's facing in the right direction. It's still off by 90 degrees. So that's good. Because I think it means that the rotation is wrong on the models, not on the... Okay, so let's do what we did last time and just do the head, see if the head's pointing in the right direction. Still pointing on the scene. How is that possible? Oh, okay, yeah, it's because 180 degrees, that's right. Plus 90 degrees. So, which is pi from 2. Excellent. Yep, the head is not processes. So let's set rot equals self.rotation. That's that. Now facing in the right direction. Great, let's put the rotation code back in. Moving, facing in the right direction. Obviously no walking animation yet, but I think we can work on that next time. Great, well there we go, that's it's been a stream of me hacking around with numbers while working on it. Hopefully someone gets something out of this. So clean up the code a little bit. So clear up the comments. These consoles everywhere. Get rid of this. And we can revert the destination back to the original code. So you should go down the entire length. Hi, hi Neff. Oh, got an error. I tried to send you a message. I got an error for some reason. It just says error. Try again. Sorry, there's something wrong with the interface. Cool, so he now moves around the entire length of the room. So I think it's probably a good place to leave it. Sorry that you've just joined, Neff, but yeah, I think it's been an hour and a half or so, so gonna call that a night. But yeah, thanks for stopping by, and yeah, I think during next time we'll try and get the animation going on the little guy and start getting some of the hit collision in as well as trying to sort out why the firebolt doesn't go in the direction it's supposed to. Oh, hi James, thanks. I'm glad you like it. I was actually just about to sign off, so thanks for stopping by. Sorry that I'm sorry that you joined right at the end. But yeah, cool. Well, take care. Have a good evening, a great weekend, and hopefully see you again next time. Bye.